Welcome back to the deep dive. We're all swimming in just oceans of data these days, and maybe the hardest part isn't finding info, but seeing how it all connects, right? How seemingly separate things actually link up. Today we're getting into something pretty significant from Google, especially for computer science and software engineering. It's their new Graph Foundation model, GFM for short. This could really change how AI handles complex, connected data. It's part of our series looking at the real cutting edge in software. Okay, let's unpack this. First things first. When we say graphs in AI, we're not talking charts and bars, are we?
No, not at all. Think more like networks, representations of data.
Okay, networks, where you have objects, those are the nodes.
Exactly, nodes. And then you have the connections between the edges.
Right, like the web itself. Every site is a node, every link an edge. Is that the kind of thing?
That's a perfect example. The link graph of the web is a classic, massive graph that shows relationships. And for years, the main tool for working with these graphs was something called graph neural networks, or GNNs.
GNNs, right. I've heard of those.
Yeah, and they're powerful for specific jobs, like figuring out a web page's topics and its links, or even predicting chemical reactions based on molecular structure. But there was a big catch, a fundamental one, really.
Okay.
A GNN was basically stuck, tethered to the specific graph it was trained on.
Tethered. So if I understand correctly, if you wanted to analyze a different graph, even one that looked kind of similar, you had to build and train a whole new GNN.
That's exactly right. A completely new model from scratch.
Wow. For a company like Google, with just mountains of different kinds of data, that must have been a huge bottleneck.
It was a substantial hurdle, yeah. And that's really the core problem that GFM is designed to solve.
Oh, okay. So here's where it gets really interesting.
This is the breakthrough bit.
Yeah.
GFM can generalize. It can understand patterns and connections in new graphs, ones it has never seen during training.
How does it actually do that, in simple terms?
Well, the process they describe is actually pretty straightforward conceptually. It takes every row in every data table you give it and turns it into a node.
Every single row.
Every single row. Then it connects nodes that are related. Think about foreign keys in a database, shared IDs linking tables.
Uh-huh.
It uses those kinds of relationships to link the nodes together into one single enormous graph.
One giant graph from potentially lots of different data sources.
Exactly. And crucially, they say this process works at scale, which for Google's infrastructure is obviously key.
And the performance numbers they're reporting are, well, pretty staggering. A boost in precision between 3 and 40 times better than older methods.
Yeah, those numbers are impressive.
What does that kind of leap actually let you do that you couldn't before? Is it just faster, or is it qualitatively different?
It's definitely more than just faster. It's transformative in some ways. Take their big test case, spam detection in Google Ads.
Okay, yeah. High stakes, lots of data.
Immense amounts. Dozens of huge graphs, all previously quite separate. Before GFM, trying to connect insights across those was, well, incredibly difficult. Like pieces of a puzzle in different buildings.
Right.
Old systems missed connections. They couldn't see the full picture across these silos. GFM, however, could bridge those gaps.
It could see links between these different graph data sets.
Precisely. Connections that were invisible before. This didn't just mean catching more spam. It meant they could identify and fight a whole new class of more sophisticated, coordinated spam attacks that exploited those previous blind spots.
That's a really concrete, powerful example. So if GFM is this flexible, this good at generalizing, what about other areas? Where else are GNNs used today?
Oh, the potential is huge.
Yeah.
Because it can generalize. You could think about applying it anywhere GNNs are already used, but maybe supercharging them.
Like where?
Well, areas like protein folding, think AlphaFold, that kind of complex structure prediction, or making social network recommendations smarter, improving cybersecurity, perhaps spotting anomalies across different network logs, even refining natural language processing by understanding deeper connections in text data.
So anywhere you have complex, interconnected data, basically.
Pretty much. The ability for one model to learn generalized patterns and then apply them to totally new, arbitrary data sets. That's the really exciting part.
So the bottom line seems to be, Google's GFM is aiming for a new frontier in AI. It's about having a single model that can handle diverse, complex, relational data and, critically, generalize to new data sets without needing specific retraining for each one.
It really makes you wonder, doesn't it? How might this ability, this generalization across vast, maybe previously unconnected data sources, how could that fundamentally change how we even approach building AI systems and solving problems in the future? Something to think about.